G'day everybody, welcome back to another episode of Crafted by Tim. Today, I'm going to be trying my hand at doing some more electronics work. So, I've got a Milo tin full of parts, and I'm going to try... Oh wow, I didn't clean that out very well. Alright, I'm going to try and turn this into a small tumbler. Now, tumblers are used for a large plethora of different reasons. Me personally, I'm going to be using it to clean metal, but you know, people use it. I saw Simple Little Life used his to rock wash knives, and I might try that later on. But for now, I'm going to be using it to clean up some steel and just prepare metal, especially as it's coming in closer to winter and stuff like that. I'm going to need some metal for some blacksmithing, so this sort of thing is going to be really handy. And what I'm going to be running it off, hopefully, will be this tiny itsy bitsy little motor here. I think it's like 5 to 12 volts, and depending on how many volts you chuck through it, will depend on, you know, how much speed you get out of it. But they've also got quite a bit of torque. I think it's like 5 kilograms per centimeter. Alright, anyway. Hopefully it will work. If not, then I'll just change out the motor. Also got some 3/16 inch threaded rod. We've got a series of 3/16 nuts there, and as well as 3/16 wing nuts. And last but not least, we also have some 3/16 or M5 flat washers, and some 1/8 by 25mm bolts and nuts. We'll also need a little bit of scrap wood to make a base for this, as well as some other minor electronic parts for this thing. But anyway, let us get on with it. Okay, so the first thing that I'm going to do is I'm going to open up my vise. So it's just big enough to fit this inside it. And what I'm going to do, okay, so it fits, pull that out, I'll grab my tape measure. So we got about 128 millimeters, which means that our center is going to be half of that, and half of 128 is 6.4. So that's going to be our center point. Well, who would have thunk it? An automatic center punch. Punch a hole straight through it. Okay, that's fine. Now I'm going to go to 3/16 for my threaded rod. Okay, so here we have like almost, well, actually exactly 4 inches. Exactly 4 inches. I didn't even like. That was a complete guess. Okay. On that side we have about 4 inches, there we have 2 1/4 inches. Now I'm going to just do a cut of recess into it, just along here-ish, somewhere there, to be able to accept this piece of ply, which I'll then cut my general shape out of. That's going to hold everything in place, something like that. Actually, no, they're upside the head box. Okay, so now what I'm going to do is I'm going to drill 25 holes into this to accompany these 25 1/8 by 25mm bolts. Okay, so now we're at the point where I'm going to start soldering the electronics part together. Okay, so minor disclaimer, I'm still not entirely sure what I'm doing, but I have a fair idea. So I've got my solder here, I've got my soldering iron already on, raring to go, and here I have a few different components. So we'll start off with the regulator. So the way that I'm going to power this is that I'm going to have 3 different methods of powering it, 2 of which aren't actually here. So first up, I want to have a 9-volt battery. This is to make sure that, you know, if this is kind of like a backup. If I can't get access to a power socket, or if I can't get a nice sunny day, I can hook it up to a 9-volt battery. But say, you know, it's not the end of the world and you have access to a power socket in your home. That means that you can hook to your mains. And for that I have I think it's a 7.5 or 7.2 volt socket, which will be good until the end of the world, in which case I can use my 9-volt battery, or I could power this with the sun. Now the main reason why I wanted to do it this way is because my dad was quite concerned that this is going to be something that's going to be running very much constantly, and if it was to be running very much constantly, then I would have significant issues with with powering this, and it's going to, you know, draw an awful lot of electricity, which is why I wanted to have a solar panel on it. As of right now, I now have 3 different power sources. One is a 9-volt battery, one is a 7 point something or other volt power outlet, and one is also a 12-volt solar panel, which means that I have a lot of fluctuation power. Now my motor here can withstand 3 to 12 volts, and you know, all of these sit well and truly within that. If I were to, you know, fluctuate between, you know, minimum of 6 volts up to 12 volts, I'm going to have a large fluctuation between how fast my tin is actually going to be rotating, and this way I can make sure that it's going to be a nice slow rotation. It's not going to be 90 RPM, but it's going to be a bit higher than, I think the lowest that it does is like 22.5 RPM. Okay, so the plan is that I'm going to use this 5-volt regulator to regulate the voltage down to 5. So I have 4 capacitors here. I have a 10 microfarad capacitor, I have another 10 microfarad capacitor, and I have a 0.1 ceramic 0.1 microfarad ceramic capacitor here. Now do take note that this side is the negative side of the capacitor, and that's going to the ground, which is the middle. On this side we have the input, and then on this side we have the output. second one is going to go pretty well opposite direction, so we have our negative on this side here. This one's our negative, and that's going to also connect to the ground, whereas the positive will connect to our output. And now for the last one, which is the 0.1 microfarad. And that's going to connect to the ground and the output. Now, as with these things, we have a heatsink here that I'm going to attach this to. This one I just pulled off another board. Where did I put the screws? Oh yeah. Found them. I need a screwdriver. Crap. Crap, I just dropped the screw. That's right. I have more. So I know it's really hard to see, but this black wire is going to be only connected to the ground wire coming off this thing. Okay, so now I'm going to attach a little switch in here to help try and keep things a little bit more organized. It's got my little crimpy things. I need that one. Basically, one of these is going to go on this side. So I'm just going to crimp it with a pair of pliers. There we go. That's fine. And I'll hook you up to that. Okay, one side done. Now all I have to do is hook up the other side. I'm out of black cable, aren't I? No, I'm not. There's some down here. So the black is my negative, and the blue is going to be the positive. Just because I don't have any red wire. Okay, so the last thing that I need to do is connect in the motor. Okay, so my positive wire is going to go to the positive terminal, and my black wire, these are negatives, that's going to go on the negative side. Okay, so now I'm going to give it a bit of a test run. So here we have our absolute cluster of everything. I'm going to make sure that this is turned off. Okay. Look at it go! I just have to get over this for a second because I just made a circuit that works. Haha! So that's one power source down. So I got this one to go. And not only that, but I also have to be able to hook up the other one somehow, which I think might actually involve me disconnecting everything and then reconnecting everything. But as of right now, this is actually working, and it is awesome. Now, I do have to note that there is no way of safely using multiple, well, as far as I understand, there's no way of safely using multiple different methods of powering this device. So essentially, if I have a 9-volt battery plugged in, I don't really want to be hooking this thing up to mains because I'm not sure what's going to happen. Well, for all I know, mains might be like, hey look, a cell, let me charge it, and then just blow up the battery. I'm not sure. I don't really know how this works. My soldering iron is still on and it's smoking. Okay, so as we can see here, you got an input of 240 volts and output of 7.5 volts at 1000 milliamps. If you didn't understand that, don't worry, neither did I. Okay, so we now have it wired up to do our secondary test. This is a test for mains. We have the 7.5 power adapter plugged into mains right now. We are about to test whether or not this is going to blow up. Hell yeah! I now have my ball bearing on here. This is a ball bearing from skateboard wheel. They're from that post-apocalyptic skateboard build that I made ages ago. Alright, so it's actually been quite a bit of time since I last checked in, and I've made a few adjustments. So first of all, I've put everything inside this tiny little Tupperware container. As you can see, it's more or less mostly the same, except for here we have 2 banana clip terminals, and they go straight into basically the power feed. One is connected directly to the intake on the regulator, and then the other one is on the ground of the regulator. But basically it just connects up the same way that the power cable connects up, as well as the 9-volt battery terminal connects up. And of course we have our little motor sticking at the end there. However, this is actually a different motor. Now it looks almost exactly the same, or at least I would say exactly the same. There is a minor change though. This one is actually the higher powered one. The reason why is because the last one wasn't actually going to be powerful enough to actually do the legwork that I needed it to. So we got a slightly fast one. The other thing that we have done is we've changed out the gears. So before I was going to use this here worm gear. So this one connects to your motor, and then this one connects to the tumbler. It wasn't giving out enough speed, so I switched it out. The more teeth that you have on the driving gear, the faster, the more revolutions you're going to get out of this per revolution of this. The tumbler is ready. Of course, we got to test out whether or not it's working. So I've got this currently hooked up to a 9-volt battery. And look at it go. It actually spins pretty quickly, and the other thing about it is it's actually nice and quiet. So brilliant, it works. So basically the way that I attach this is that I've got in here the motor is currently glued to the inside of the box. I have this container glued to the top piece of ply, and the bottom piece of ply I've drilled 2 holes in, and I've just put 2 screws that basically just make contact with like half of this plate. This way that it's not going to fall apart on you or anything. So I guess the point of the time that we're at now is that we got to test whether or not the solar panel works. Okay, so as you can see, it's not plugged into there, it's not plugged in at there. This is just the solar panel, and it's actually a pretty overcast day. Like, there's not an awful lot of sun coming through. Yet, we're still getting pretty good results, so that's still spinning pretty fast. Can it perform its designed purpose? Okay, so here we have the tumbler. So it's all finished up. What I'm going to do is I'm actually going to load it up with some brass bullet shells. So if you guys will remember a little while ago, a friend of mine helped me out with the filming part of making that trench lighter. Anyway, that's inspired him to work with a few of his bullet shells himself and make a few of his own little things. And I'm happy that I could inspire you to do that. But I went around his house recently, and he was like, "Oh, I have something for you." So I asked him for whether or not he had any spare brass. He was like, "What caliber?" I was like, "Any." And he's like, "Well, I've actually been saving 22 bullets for you, and I've been drilling out these holes." So he's actually gone to all the effort to drill out every single one of these bullet shells, which would have probably like, it's a decent effort. So thanks, man. So what I'm going to do is I'm just going to pour these straight in. Actually, I'm going to take out 3 at random. I'm not looking. I know you can't tell, but I'm not looking. So those are the 3 that I'm going to take. Now these are mostly clean brass, but on the inside you can see that are a little bit, you might be able to see that they're a little bit mucky. Anyway, they're a little bit mucky on the inside. So what I'm going to do is I'm going to pour these all in here. That was loud. And I'm going to get this open. What I'm going to do is I'm going to take 1 full cup, so we have about ½ a cup of brass, of this tumbling media. This is corn cob tumbling media. And I got this from an actual gunsmith. No. Okay. So once again, it's been a little while since I gave you guys an update. It's been a few days. And I altered this again. So this time I went back to the old motor, so I get less RPMs but a higher torque. And as you can see, it works perfectly fine. That is up until I put the actual tumbler on it. As you can hear, there is still stuff in it. However, there's significantly less. And as you can see, it doesn't work. So the problem here is, there's 2 problems actually. So the first one is that the motor isn't actually really strong enough to drive this. And on top of that, the glue isn't bonding enough to these gears, in which case the gears aren't actually spinning. Like, I can stop this with my hand and the motor is still going around, but the gear is not. So I'm actually out of time for this project, which is annoying because I was really hoping that this would work. I do have another idea that might sort of fix this problem, but it won't be involving electronics. And this entire setup, even though it was very educational for me, doesn't work. However, if I were to get a stronger motor that could run off that the low 5-volt output that still only has, you know, 90 RPM or something like that. This could very well work, but unfortunately I don't really have the means of doing that. I don't have the motor for that particular application. Now, of course, I could probably go out and find one. I have had a decent look on the internet and I'm still yet to find anything. So if I do return to this and if I manage to fix it, I will definitely keep you guys posted. But as of right now, I'm going to have to shelf this one. And actually, I will be returning to this, but I may not be doing it electronically. I might be doing a mechanical fix instead. And I think that one will probably work a lot better. And it'll be definitely a little bit more interesting. So, unfortunately, yeah, it didn't work. But I will be coming back to you guys with a different project next week. And I might be returning to this one in, you know, a few weeks. I have to iron out the kinks so that I reckon I can get this to work in some way or another. Thank you everybody so much for watching. So don't forget to subscribe, stay safe, happy crafting, and as always, cheers.